Hello, everyone. You are welcome to today's meeting. And in today's meeting, we are going to continue from where we left off on the topic variation. So our last meeting was lesson 1. Okay, and in lesson 1, we looked at, okay, the definition of variation, the various types of variation, and, okay, we took 2 of the types. We mentioned 4. Direct, indirect, which we also call the inverse, then the joint or mixed, then what's the partial variation. So we did direct variation, indirect or inverse variation in lesson 1. Okay, questions regarding that. In lesson 2, we are going to consider the last 2, okay, of the types. And the last 2, the first one is what we have on our screen, the joint or mixed word variation. Okay, so quickly, let me read. This is a type of variation. Okay, sorry, this, I should have said, this type of variation combines, not this a type of, if I wrote this a type of variation that combines, that should have been the appropriate, okay. So the English here is more or less smart English. Okay, so let me take it to, but that's just by the way, I will do the correction later on. So this is a type of variation that combines direct variations or inverse variation or both. Okay, it therefore deals with the product of 2 or more quantities. Okay, remember I said the quantities basically will be represented by variables or will be regarded as what? As variables. Okay, as simple as that. So take note. So when we are dealing with joint variation, okay, you join your 2 or more variations with products. You use what? Multiplication. So take notes. That's why I said it deals with the product of 2 or more quantities. So for joint, we'll be multiplying our variables. Okay, we'll come to the partial one and we'll see the operation that will be involved. Okay, so quickly, just as we did for the first 2 types, we are going to look at the statement and how to move from the statement to the mathematical representation. Okay, and therefore the relation. Okay, so let's see. If you look at the first statement, and I believe your attention, I have your full attention. If you look at the first statement, y varies directly as x. So we know that from where we are coming from, if y varies directly as x, this will come from the statement y, oops, forgive me, let me go back. So it will be y varies directly as x. So it means x will appear in the numerator. And the same y, okay, so and okay, you are told the same y will vary, okay, we said, also directly at z. So this is what you have here. So you can see y varying at x and the same y varying at what? At z. Okay, as z. So in this case, if you move from here to the to the relation statement, we know that this will give us y is equal to kx. Do you agree?
Yes.
Okay, and this will also give us y is equal to kz. Do you agree?
Yes, sir.
Okay, so now I'm building your concept for you to generate, okay, the mathematical representation in terms of what the joint or mixed variation. So please, okay, give me your maximum attention. But you can see that I have k here, I have k here. So I want to distinguish between these 2k. They will not always be the same. In special situations, their values will be the same. So in order to distinguish between them, I'm going to use k sub 1 and k sub 2. But they are all constants of what? Variation. Is that clear?
Yes.
Okay, so here we are going to combine these 2 statements. Okay, and remember we said for joint we multiply. So we are going to multiply this statement and this statement. So you know already we have y here. So it means y will be equal to the product of k sub 1 x, okay, and what? K sub 2 z. Is that clear? Okay, so can I say that this will be equal to k sub 1 times k sub 2 xz? Do you agree? Can I say that? Hello,
Yes,
who wants
sir.
me to come again? Who is somehow lost?
Please come again.
Okay, from where? My professor.
From y is equal to k1
Okay, so it's just like
X.
you are multiplying is K1 X, you are multiplying letters, okay, in algebra. Okay, it will be K1. Okay, I want to bring all the K first. So if you like, okay, if I ask you to multiply A, B times AC, what will you do? Or maybe times CD. Wouldn't it be A, B, C, D? So I'm just multiplying the letters there. You get it? But I decided to write the K1 and the K2 first. Times, so it's K1 times K2 times X times Z. Is that clear?
Yes, please.
Okay, but we know, okay, remember K1 is a constant, K2 is also a constant. So if you have a constant times a constant, are you going to get a variable? If you multiply two constants, what do you get?
A constant.
You get a constant. So if I multiply 2 and 3, which are constants, I will get 6, which is also a constant, not a variable. So in that case, the whole of this constant, these two constants, I'm replacing it by what? K. So that would be, give me K, X, what? Z. You get a point. So it means, just as we did for the direct and indirect, okay, we will introduce only 1K for joint or mixed variation as well. So now that we get this is what we were expected to write. So this implies that straight away, you should write this. Y varies directly as X, so it will be X. And again, directly as Z, so it will be Z. You can choose not to split. Now you are matured. You know that you come and multiply. So in this case, I will write, oh, sorry, it doesn't, the implication shouldn't come here. Okay, let me clear the implication. Okay, later go and remember, I want to be consistent. Then later we'll use the implication to get to the statement. Okay, Prof. Herbert.
And sir, please, you said K1X times K2Z. Sir, please, your answer, shouldn't it be K square XZ?
Oh, no,
I don't
no, no,
understand.
no. No, K1 is different from K2. Okay, K sub 1, K sub 2. If it was KK, then it would be K squared. That's why I said I'm distinguishing between the two of them. So meaning they are different now. Once they are different, they cannot take square. You get it? Square will come in when they are the same. Is my point well made?
Yes, sir.
Okay, great. All right. Okay, so now this is what we have. So in this case, this implies that, okay, I've broken this one down and you know where that is coming from. This is coming from. So it will be K varying as X and Y varying as X and the same Y varying as what Z directly. So now it will be K, Y is equal to, immediately I introduce what's equal to, then K comes in and it will multiply the XZ. Where again, you are told that K is the constant of variation or proportionality. Is my point well made, my professors?
Yes, sir.
Okay.
Yes,
So you can see that unlike the, what do you call it? The direct and indirect. Okay, direct and indirect, we were dealing with always, we deal with two variables. Am I right? But here, how many variables can you see? How many variables, even in this? How many variables do you see in the statement?
3.
3. Okay, so that's why I said it deals with 2 or more. So this one will be 2 or more. So, but here you can see that Y is related to this, and you have 2 variables. For the direct and indirect, to always be 1 variable. Take note. Okay, so now let's look at Y varies jointly as X and jointly as Z. So you can see that this statement here is basically the same as this. Do you agree? Only that from the first one, you see directly as X and immediately N comes in. You should also know that you are dealing with what? With joints. Okay, or mixed. That's the more reason why you multiply these two variables. So here, the keyword is also seen there. Another keyword, jointly. So you should know that you are dealing with joint variation. So this one too will be Y, okay, varies, we said jointly as X and Z. So it will be directly as what? X and what? And Z. So this will also imply that Y will be equal to K, okay, X, Z. Should I come again, or my point is well made? Where K is the constant of variation. Is my point well made?
Yes, sir.
Okay, great. So now let's move on to That's of what the third statement. Okay, y varies directly as the square of x. So it means y is going to vary. Okay, so y varies directly as the square of x. So the square of x will occupy the numerator because it is direct. Is that clear? Okay, and so let me break it down here for the benefits of those maybe who will have some doubts as to why we have that over there. So I'm going back to what I was doing previously. So y, the first statement is saying that y varies, okay, directly as the square of x, so x squared. And the same y is varying, okay, inversely as what? As z. So it will be 1 over z. Do you agree?
Yes, please.
Okay, so you know, joint deals with what products, and we know that there's a joint variation. Okay, so now this will be y varies, then you come and multiply this. So that will give us s squared over z. Do you agree?
Yes.
Okay, so now, like I was breaking it down, directly as the square of x. So square of x should occupy the numerator. Then inversely, so once inversely comes in, the denominator should come. And inversely as z, so your z should come. Okay, now this implies that, okay, unfortunately, I don't have space here, so I am going to write my implication here. Y will be equal to, then I introduce my k. So the k will come and multiply the numerator. So it will be k x squared over z. All correct. Hello.
Yes,
Oh,
please.
okay. All right. So, okay. So now let's see who can help me. I want someone to help me with the last statement, how you write it. Okay. If you know, you put up your hand if you want to try. You put up your hand, then I will call you, okay, to deal with it. Okay. All right. Prof. Natalie. Okay. Let's go.
The statement says y varies inversely as x and inversely as cube of z. So since we know that if you get a variation with an inverse variation, meaning there's supposed to be a denominator.
Very good.
So if y varies inversely as x, it is y variation sign 1 over x.
Over X.
Same
Very good.
y varies inversely as cube of z. So you just combine them, you get y varies inversely as 1 over x times cube of z.
Very good. So Z cube. Is that clear? Please, do you all get her?
Yes, please. Yes,
Okay,
please.
very good. So now there's the variation statement. So let's move to the relation statement.
Okay, so y equals the constant of variation k over x z cube.
Perfect. You are done. As simple as that. So as you mature, you don't even need to go and separate before you come and write what's the exact statement there. Because this is where we'll give the marks. We won't give the marks at the statement. But if for convenience sake, okay, you want to do this, you do that as your rough work. But we are interested in the overall variation statement, which will move you to the relation statement. All correct. Okay, so thank you very much, okay, Prof. Natalie. Okay, so on that note, now I think we are in a good position to look at what some examples under this type of what variation. But before that, any questions? Now, professors, are we all fine so far? Okay, we thank God. So I'm going to move on. Now let's look at our first, okay, worked example. Okay. A quantity z varies directly as x and inversely as the cube of y. So immediately you see, okay, your quantity varying, okay, with more than or yes, more than one variable. Then obviously what should come to mind should be the joint or the mixed variation. And again, when you see end, and remember end in math, usually, I think I've said this before, usually we consider that as product. I hope you get it. Multiplication. Okay, so it will vary as this n so times it's varying as that. Okay, so quickly, let's look at the solution. When you write, okay, after reading the question, there is no salient part for you to underline. Here, you only need the, okay, so if I like, I can write, find the relationship for Z in terms of, okay, so in terms of X and Y. So meaning until my Z is in terms of X and Y, I don't stop. Any other letter in there must be out. Okay, so at this point, I write, okay, question number 1, solution to question number 1. Then my variation statement is key. So given, okay, we are told Z varies, and we saw directly as what? X. So X should occupy the numerator. And inversely, once inversely comes in, then over the cube of Y. So it will be Y cube. All correct?
Yes, sir.
Okay, very good. So now this implies that, okay, we are going to move from the variation statement to the relation statement. So Z will be equal to K. Once we introduce equal to, we introduce the K as well. So it will be KX, okay, over Y cube. Okay, now you've introduced K. And again, don't forget to, okay, define your K. So your K is equal to, here, K was not defined. So when you introduce your K, you can go for the variation constants. Okay, or a constant if you like, but I said, okay, throw a little more light on the type of constants you are dealing with. Okay, so now at this point, you are in a comfortable lead. Okay, before this relation that we have here is in terms of K, X, and Y. Okay, so Z is in terms of K, X, and Y. Meanwhile, the question is demanding from us, okay, to express Z only in terms of X and Y. So it means this K must go. So we need to find the value of this K. In order to find the value of this K, the question should give you the values of X, Y, and Z. So let's see whether we have that. Yes. Okay, so now this is what we are going to do. So here, if, even if it was when, I've told you always use if. So if, okay, Z is equal to 2, we are told that X will also be equal to 2, and, okay, Y will be equal to what? 1. So we come and substitute. So this implies that Z is 2. So it will be 2 is equal to K times your X, and X is also 2, all over your Y, and Y is 1. So 1 cube. Okay, so please don't forget the power, very critical. Okay, so now what do? We are going to get 2 to be equal to 2K over 1 cube, we know is 1. Is that clear? Okay, someone can choose not to write the 1. The 1 is there simply for explanation purposes. So now you are looking for K. So you write it again before you divide. So over 2 over 2. Okay, so K will be equal to 1. Now, once you know that K is 1, then you can come and substitute and you get your relation in terms of what? In Z in terms of X and what? And Y. So I will draw my conclusion at this point. Therefore, okay, my Z will be equal to K, which is 1. I won't write it, simply understood to be there. Then X over Y cubed. All correct?
Yes, sir.
Okay, very good. So this becomes, okay, the first example. I think I should have done something that I didn't do. Okay, no problem. Okay, I wanted to place it side by side. Let me see. Okay, so it's okay. Let's move on. Okay, so that will save space, but it's okay. Okay, so question 2. This is what we have. Again, similar to what we just did. Okay, the question is also looking for only a relationship. So let's go and look at the solution. But before the second one, please, the first explanation, are we all fine?
Yes, sir.
Okay, great. Okay, so let's look at 2, solution to 2. Okay, we are told a quantity Z varies directly as the square root of X, and inversely. So immediately you see varies directly as this, and also another, okay, then we are talking about joint. So we have, okay, given, and the first quantity is what? Z. Okay, our quantity of interest. Okay, varies, we are told, okay, directly, so as the square root of X. So square root of X should occupy the numerator, so square root of X. Okay, and inversely as the cube of Y. So the denominator will also be Y cubed. Okay, because it's inverse, it becomes a denominator. Your quantity or your variable becomes a denominator. So there again, we are going to get, this implies that you introduce your k. So z will be equal to, immediately you introduce your equal to the k comes, it's okay, we'll multiply the numerator. So it will be k root of what? Root of x all over y cubed. All correct. Is anything missing? Hello, is anything missing?
You didn't define the k.
Perfect. Okay, so once you are able to correct me or draw my attention to that, please. Okay, you have no business not to do that for yourself. So now you introduce your k, so you have to define your k. So this will be, k will be equal to what? Variation constant. Okay, so now what do? We want the relationship of, for z in terms of x and y. Z is in terms of x, y, and k. So again, we need to go and find the value of k. So if, okay, yes, please, Prof. Natalie.
So please, if let's say you want to find the relationship, and then you are supposed to find k first, the constant of variation. So can you make k the subject before you input the values to find
If not,
k?
why not? I won't even allow you to learn. If not, why not? Okay,
Okay.
you can make k the subject before you substitute. Only that I will advise you substitute before you make k the subject, because sometimes if you make k the subject, because you'll be dealing with letters, if your change of subject is wrong, you are doomed as well. You get it?
Yes, sir.
Okay, so if you want to go that route, then make sure your change of subject is on point. Okay, all right. And you know, dealing with, if you substitute before you do your change of subject, dealing with numbers usually is easier than dealing with variables. You get it? You
Yes, sir.
relate very well with numbers than what? Variables. And you agree with me?
Yes, sir.
Okay, very good. So always carry out your substitution in terms of the numbers before you do your change of subject. It's better. Okay, all right. So now if z is equal to 8, equal to 8. Okay, we know that x is equal to, and remember you can see when there, please always use if. Okay, 4. And y is equal to what? 1 over 2. So I'm going to substitute these values, okay, in their corresponding, okay, places. So now I will get, this implies that my z will be equal to k. I don't know k, that's what z I know, forgive me, that is 8. Okay, it's equal to k, I don't know. Okay, into root of x, I know that is 4. All over y cube, y is 1 over 2, and it will be 1 over 2 cube. Is that clear?
Yes, sir.
Okay, so now what do we do? This is 8. Let me clear it so that it will look nicer. Okay, then write it well. Okay, so 8. So now, first of all, let's come and work on this side. The numerator and the denominator, we can work on it. So we keep the 8 is equal to, then this will give us what? K times 2. Is that not it? Because root of 4 is 2. All over, okay, this will give us 1 over 2 cube will give you 1 cube, which is 1, then 2 cube, which is what? 8. So 1 over 8. Do you agree?
Yes, sir.
Okay, so in effect, we are going to get, okay, somebody can say that, let me clear the fraction. Okay, multiply this, clear the fraction. So if you are clearing the fraction, then it will be 8 times 1 over 8. So let me write that anyway. So 8 times 1 over 8, okay, is equal to what? 2 times k, which is 2k. All correct.
Yes, please.
Okay, so you know that this will also cancel that. So we are going to get k, okay, let me come here, to be equal to what? So it's 2k rather, forgive me. So 2k will be equal to what? 1. Do you agree?
Yes, please.
Okay, so now we are looking for k. Okay, not 2k. So you write it again before you divide over 2 over 2. So your k will be equal to what? 1 over 2. And once you know k, you are more than, okay, comfortable, okay, to get your relation in terms of whatever that you are looking for. So now what do? We draw a conclusion. So therefore, okay, I am smart. I can draw my conclusion and I know equally you are. So you should be able to do that as well. So I'm going to get, okay, Z to be equal to K, and that is 1 over what? Over 2. So I know that the 1 will multiply this and the 2 will come and multiply the denominator here. Is that clear?
Yes, sir.
So I'll write this as root of X, okay, over, okay, 2y cubed. Those of you who doubt, okay, this is what you were supposed to do. So it should have been this, okay, it's equal to, if you are not mature to get it straight away, it's equal to come and substitute directly, and that will give you half of what? Half times what? Root of, okay, X, okay, all over, okay, y what? Cube. So in effect, you know that is the same as, okay, root of X over 2. Okay, the whole of that divided by y cubed, which in effect will give us, am I right? Okay, which in effect will give us root of X over 2 times what? 1 over y cubed. Okay, so that gives us what? Root of X. This will multiply that, and this will also multiply that, which is 2y cubed. Okay, as simple as that. But I've told you, anytime you have a fraction, okay, being divided by another, the denominator will come and multiply the denominator of the other one. So that will give you what you have there. So as simple as that. Point well made, my professors.
Yes, sir.
Okay, so now if you know how to get the relationship, once you get the relationship, you should be able to predict Z given X and Y. You should be able to predict X given Z and Y. You should be able to predict Y given X and Z. Okay, so take notes. Okay, and that is what we are going to do next. Okay, so let's see what we have there. Okay, so question 3, before we come to question 3, are we all fine, my professors?
Yes, sir.
Okay, great. Okay, so now question 3. Quickly, let's
Can you
get.
go back with I've
I should go
seen
back. You want to capture?
yes. No, but then say you wrote half squared as 1/8.
Yes, it's 1 over 8. You disagree? It's not half squared, oh, sorry, it's half cubed.
Oh, okay. But you wrote okay. I can see two. That's
You
what
want to tell me that my handwriting is not legible? I won't mind you. All right, okay, so it is 3. Please take notes. All right. Okay, so that's, in any case, I'm taking it from here, so you should know that it's connecting from here. Okay. All right, so if that's the case, then you don't have any problem. Okay, so 3. Okay, so y varies jointly. You can see the keywords there, so the work is easy. We know that we are dealing with joint variation as what? X and the square of what? Z. So in this case, we are going to get, given y, the variation statement should come, okay, varies jointly as X and square of Z. So X is a numerator, Z is also a numerator, which is the square of Z. Is that clear? So we are going to get X, Z, okay, squared. So this implies that your Y will be equal to K, okay, X, Z, okay, squared. Then you don't forget to define your K. K is equal to variation constant. It wasn't defined here, so we are, okay, we'll go our usual definition, variation constant. All correct, my professors.
Yes, sir.
Okay, so quite a pretty relation. No fraction, okay, no square root, what have you. So it's a pretty one. Okay, now A, we need to find Y in terms of X and Z. So K here should go. So we are now going to look at how to find, okay, Y in terms of X and Z. So A, okay, and that's where you pick the values. If you can get Y in terms of X and Z, then we need to give you X, Y, Z values to find your K, which you have been provided over there. So it's when, but don't use when. If, okay, X is equal to 3, okay, Z is equal to what? 2, and okay, y is equal to 60. Okay, now what are we going to get? This implies that, okay, y, what is, we said this is the relationship y, and y is what? Is 60. Okay, should be equal to k. You don't know. That's what you are looking for now. Then x is 3. Okay, 9 times what? Z squared. Z is 2. So 2 squared. All correct.
Yes, sir.
Okay, so at this point, we are more than good to go. So again, we get 60. Okay, it's equal to, this will give us, this is 2 squared. Let me write it well. So let's go and deal with the power first. So we are going to get k into 3, deal with the power, and 2 squared will give us 4. Am I right? So 60 will be equal to 3 times 4, which is 12 times k, so 12k. Okay, we are looking for k. We write it again before we divide. So it's equal to 60 over 12, okay, over 12. So we'll get k to be equal to 60 over 12 will give us
5.
okay, please, you know, k again is a means to an end. So you don't write therefore k is equal to this. Please take notes. What you were asked to find is the relation, okay, of y in terms of x and z. So that's what must take your therefore. So the best that you can do here is to use implication. You cannot use the therefore for k. So now that I know k, I go and substitute k into this, then I will know my y in terms. So I'll write therefore my y will be equal to k. I know is 5. Okay, then I will get x, z, okay, squared. So now y is in terms of these two variables, x and what, and z. All correct.
Yes, sir.
Okay, great. So, okay, so that's it for only A. We have B and C to go. And like I said, once you know your exact relation, okay, I can predict Y given these two unknowns or variables. I can predict S given the other two variables, Z given the other two variables. So that's what we are going to do there. So B, okay, when X is equal to 8, okay, so if X is equal to 8, oops, X is equal to 8. Okay. And what? Z is equal to 0.4. Not pretty, but we'll work with it. No worry at all. We have our, at least we have our calculators. Okay. So now this implies that we are going to substitute. So y, we don't know y. We are predicting y. So y will be equal to, okay, 5. Okay, we said times our x. X is 8. So 8 in brackets, then times the z squared, and z is what? 0.4, okay, squared. So here we are going to use our calculator. First of all, deal with the power. Okay, so let's go and work on the power. So this gives us what? 5 times 8. Okay, let's keep the power first. Okay, so the power first. This gives us 0.4 squared, 0.16. I'm waiting. My professors.
0.16.
Okay, so 0.16. I want you to contribute, that's why. Okay, so 0.16. Okay, and at this point, you can use your calculator, okay, straight away to do everything. So I will write, I've not done my conclusions. I'll write therefore y is equal to my calculator value. I'm waiting.
6.4.
Okay, 6.4. Okay, because you have decimal, your answer likely will also be in decimal. Do we have any units? No units for y. So you leave it there. So the last one, z, we want to find z. So, okay, y is equal to, if you like, you can choose not to write if indirectly. You can choose not to write when. You can write y is equal to, okay, 5. And, okay, x is equal to 0.1, only that it will carry more sense if you use if. Okay, all right, otherwise it will not be costly anyway. All right, so now we just need your value. This implies that we are going to substitute. 5 will be equal to, okay, we are substituting that into the relation. So 5 times your x, do you know x? Yes, and that is 0.1. okay, then times your z, okay, squared. You don't know z, so it will be z squared. That's what you are looking for. So at this point, let's come and work on the coefficients of the z. So 5 will be equal to, okay, 5 times 0.1. I'm waiting, my professors.
0.5.
0.5. Okay, so you should know this. So 0.5, which indirectly is half, then z squared. So now you are going to write this again, then you divide by 0.5. So it will be 5. Okay, 0.5. Okay, z squared. Okay, is equal to 5. Then over 0.5 over 0.5. So that will give us z squared is equal to
10.
10. Okay. So now at this point, we are looking for z. Okay, so let's see. Okay, we are going to get root of z squared. Okay, should be equal to, do I introduce plus or minus? Hello, do I introduce plus or minus? Or you are thinking through?
Yeah.
Okay, so we are going to introduce, but going forward, I will advise. Okay, so for now, let's keep it like that. So plus or minus, okay, root of what? Root of 10. Okay, so we are now going to draw our conclusion. Okay, so at this point, I want the exact value. Therefore, my z, okay, will be equal to, root of 10 is in its basic form. So I'll write, okay, root of 10, or remember I said don't conclude with a plus or minus together, always separate, or minus root of 10. All correct.
Hey. Okay.
Hello, are you with me?
Yes, please.
So what was the A for? Okay, so always separate, don't conclude the plus or minus together. So if you want to conclude with decimal, that will give you an approximated value. Because as I said, you always approximate. And immediately you realize that, okay, what you are going to deal with will be an approximated value. Please avoid if you can write the exact value there. Am I clear, my professors?
Yes, please.
Okay, great. So on that note, this takes us to, okay, possibly maybe our last one, but one, okay, under this, okay, particular one, or maybe the last one. I think we have to do more anyway. All right, so now this is what we have. Okay, let me see if someone will volunteer to do this one for us. You tell me what you would write. Okay, otherwise then I will call you at random. Okay, so I am thinking of doing the random calling when we are solving, okay, or giving the solution to past questions or likely exams questions. But today I want you to, okay, volunteer. Don't push me to the wall to, okay, call names. Oh, my professors. Ah, what is happening? I'm waiting. Oh, at least I should get someone by now. Okay, Profella. All right, let's go.
Okay, so given
Just giving.
no 4.
Okay,
4.
very good. Okay.
Sorry. Yeah.
Mhm.
Given W and the
Variation sign. Okay.
variation sign, yeah. U
Mm-hmm.
all over
Mm-hmm.
square root of V.
Square root of V. Very good. Mm-hmm.
Yes. So there are sign.
Which sign?
You know what I mean. They're
I
equal
don't know.
to,
I don't know. I don't know at all.
which implies that yes.
Ah, speak the language now and let me know that indeed you are my professor. Implies that
W
W
is equal to
is equal to
K
K
E
U. Okay,
all over
let me write the
square root of V,
all over square root of V.
comma, Ka is equal to variation constant.
Very good. So far, so very good.
So substituting the values, we have
Okay,
the
so
next
what do you
point.
write first? So if
If W is equal to 5,
mm-hmm,
U is equal to 10,
mm-hmm,
and V is equal to 24,
okay,
we get, which implies that 5 is equal to K, bracket opens, 10,
very good.
bracket close, all over
Mm-hmm.
square root of 24.
Okay, very good.
Yeah.
Let's go.
Square root of 24. Yeah.
Mm-hmm.
So we are going to multiply the square root with the 5.
Okay, so you get 5 roots of
5
24.
times 24. Yes, please.
Mm-hmm.
It's equal to 10K.
Very good. Mm-hmm.
Yeah. This will give us 5 square root of 24 will give us 10 root 6.
10 root 6.
Yes,
Okay.
please.
Okay, so 10 root 6. Okay.
Yes,
Will be
please.
equal to
10 of K.
okay. Mm-hmm.
So comparing, no, we can't compare it. You can't compare it.
Oh, but you
So
can compare. You can compare.
you can
You
can
are going
compare.
to be very smart. And immediately you said comparing, I was so happy. You can compare.
Okay.
Okay,
So
sometimes that's
then
what we do. That's not to cut you anyway. That's what we do. But usually we won't tell you to compare. We'll tell you to write it again and divide. Because if this is 10, this is 10. I can clearly see that K is root of 6.
Yes, please.
But let's go the usual route. Is that okay?
Then okay.
Okay. All right.
So you write it again, you rewrite everything, but this side bring 10 of K first is equal to 10 root 6.
Okay.
Dividing both sides by K, by
K?
10, sorry.
Okay, all right.
By 10, we get K is equal to root of 6.
Okay, perfect.
So that's the first part.
Uh-huh.
So then you write the relation. K.
Can I write there? Should I write therefore?
Yes, please, because we didn't start with therefore. You can write therefore.
So I should write therefore.
Yes, please.
W is equal to.
Therefore, W is equal to root of 6 U all over root
at
of.
this point, I don't agree with you.
Why?
Okay, because the question didn't ask us directly to find a relationship, so we don't conclude with that.
Okay.
You get it? Your conclusion should be when you are finding the value of W.
Yeah.
You get it?
Yes, please.
Okay, so the best we can do is what? Implication. So this implies that W.
W is equal to U root 6
Very good.
all over root of V.
Root of what? V.
Yes.
Okay.
Please.
Why didn't you write the value of root 6? Okay, there in terms of decimal.
In terms of this,
it
will make it like complicated, and will be estimating, which will make the value wrong.
Okay, very good. It will be an approximated value. That's what I just said. Avoid that if possible. Okay, so very good. So far, so very good. So now, the final part.
Yes, please. Therefore, W is equal to.
Okay, so won't you extract any values?
Okay. If U is equal to 3.
Okay.
V is equal to 6. Therefore, W is equal to 3 root 6 all over root of 6.
Okay.
So root 6 cancels root 6.
Okay. So that will
The-
give us
W is equal to 3.
3. So if you had approximated, please take note. You can see that assuming maybe you wrote something here, okay, your approximation, which you write more anyway. Because remember I said if you are going to approximate, your first approximation should be 4DP. So you can see what you write. If you are going to write a 4DP version of this and the root of what's that. And here, because you didn't, you can see that this canceled out. Okay, exactly. So you had what? A pretty what result. So thank you very much. Okay, Prof. Ella. Okay, proud of you.
No.
All right. Okay, so that will be it for this question. Okay, all right. So now, any questions before we move on to the next one? Hello, my professors. Any questions? So we are all fine. Okay,
Yes,
great.
sir.
Okay, so, okay, Prof. Bliss.
Mr. Hackman,
Yes, please.
please can you use the concept of rationalizing the denominator for this step?
Okay, for this step,
The 5 is equal to k into 10 over root 84.
this one.
Yes, please.
Okay, you know, definitely you are going to clear this. Is that not it? You cross
Yes.
multiply. So when you clear it, it will no longer be a denominator for you to call for rationalization.
Okay.
You get it?
Yes, please.
Okay, because if you rationalize, you realize that the numerator will also come and take root of what? 24, which will later you have to also divide by root of 24 because you are looking for k.
Okay. Yes, please.
So you come back to square one, basically. So once it's an equation, rationalization shouldn't be, okay, I mean, of a border. Okay, talk about you cross multiplying, clearing that, as simple as that.
Yes, please.
Okay, all right. Thank you very much for the question. All right, okay, so now we can move on to our next one. So take notes of this question. Take note of this particular question. And you know, the color alone should tell you something. Okay, so take note of it. Okay. And now another one. Remember in one of, I think it was a direct one, I gave you a situation where the question came in a table form. Okay, the indirect one too, we could have gotten a table form question, but we didn't deal with that one. Okay, with this particular type, we are going to deal with what? Another table form question. So if you're able to do this, then it means any question at all, okay, you should be able to deal with it because questions will come, okay, under these two types, the direct one and the table one. So let's look at the table for the joint variation. Okay, so quickly, hey, so this one, let's do it together. At least I will be interested in the relation. So I will call someone to give me the relation, then we continue from there. Okay, so question solution to question number 6. Okay, so if for nothing at all, we know we write given. So let's go and read the statement and get the variation statement. So like I said, I will call someone to help me with this. Okay, so let's see today who has not been on my radar, okay, yet. Okay, so let me see. I saw some names, pretty names somewhere. Okay, Prophet Ra, let's go. Prophet Ra, are you there? Please unmute and let's go. Hurry up. Remember, if I call you, if you have issues with your audio, send me a chat. Otherwise, first of all, I will give you a yellow card. I'll come and call you again. If you don't respond, then I will assume you've joined the meeting and you've left. And okay, if you fault me for that assumption, okay, please, I will not agree with you. So Prophet Ra, unmute and respond. Otherwise, send me a text if you have issues where you are, if it's not easy and you can't respond, fine. Okay, so I've given you yellow card. Prof. Andrea, let's go. Prof. Andrea, are you there? So Andrea, Eura, okay, you are on yellow card. All right, okay, Prof. Let me, Hilda, let's go. Hello, can you hear me?
Yes, please.
Okay, so it's just that they can hear me. They are supposed to hear me.
Yes.
Okay, Prof. Hilda, are you there? Let's go.
Mr. Ackman,
Yes, please.
the relation given P varies as R and inversely as the square of R.
So what will you write?
P
Mm-hmm.
and P and then
You can do it. Let's go.
Mr. Ackman,
P varies. If for nothing at all, P varies. You know the sign should come. You get it.
yeah,
So
yeah.
the sign, the variation sign. Let's go.
Then the R
Okay. R numerator or denominator?
denominator.
Denominator.
No, R numerator over
Okay.
the square of Q.
Okay. Q denominator. Q square denominator or numerator?
Denominator.
Why denominator?
It says R and inversely as the square of Q.
Okay, so yes, P varies inversely as well. So once the relation is inverse between them, then it becomes what? The denominator. So Q squared. Very good. You are in a comfortable list. So give me the relation.
P
P
equals to K R over Q square.
Okay, very good. And what do you write?
Where K is equal to the variation constant.
Okay, so you can see that it's obvious that you didn't read through the question. You didn't finish. Okay, Era, okay, so I've withdrawn your yellow card. I'm trusting that, okay, you are being honest with me. All right, okay, so please, if you are not being honest, then you are not helping yourself. That's just by the way. Okay, so if you had read through the question, and remember, you don't read questions in isolation. This is a full question. So make sure you read everything before you start solving. So at this point, you would have known that your value of the constant of variation, okay, it's better you define it as well, constant of proportionality, because you have that in the question. Is that clear?
Okay.
You get a point. Okay, so just as you saw in the assignment, so you write constant, of what? Okay, proportionality. All correct, my professors.
Yes.
Okay, so now you can see what we have here is basically the results that we have there in terms of what? P, in terms of K, R, and Q. Okay, however, forgive me, sorry. Okay, find the relationship between P, Q, and R. And usually when we are looking for that relationship, we want you to, okay, get the value of K and substitute. And once you know, the next point is to find the value of K. You should know that we are going to find B first before A. Is that clear? Okay, as you are going to substitute and find the value of K, you know you are solving for B. Am I right? Okay,
Yes.
so quickly, let's do that and see. So I am going to do B. Okay, if from the table, I know that if P is equal to, okay, because I need to know this. So which column do we have all the values of P, Q, and R?
The first one.
Okay, so indirectly meaning
First
the second column rather. This is the second. Okay, so there's the first column, second column, third, fourth. Is that not it? Okay, so you mean this. So when P is equal to 6, okay, Q is equal to what? 1, and what? And what? R is equal to what? 1. So instead of giving you the statement in this form, it has been given in the table form. So this implies that, okay, your P, which is 6, should be equal to K into R, which is 1. Okay, over what? Q squared, which is 1 squared. Okay, so we are going to get 6 to be equal to K. 1 times K is K. Okay, all over 1. This is just for itself. So it means, okay, therefore, my K, which I said is the constant of proportionality, is equal to what? Is equal to 6. All correct.
Yes, please.
Okay, so now with the K, we can comfortably answer the question for A. Do you agree?
Yes,
Yes.
please.
Okay, so therefore, now you know the relationship between P, Q, and R. So it will be P should be equal to your K is 6 now. So 6R over what? Your Q squared. All correct.
Yes, please.
Okay, so now the last part, copy and complete the table. Okay, so at that point, I'm going to do something. I will go back, okay, a little. Okay, I will move from the presentation view to, okay, the other view so that I can copy the table and paste. Okay, but let me, okay, pause here. Okay, so we've copied the table. That's what we have there. Now, okay, our duty is towards complete. And you can see that you have only 2 missing values that we are supposed to find. So the work shouldn't be, okay, difficult. So if once I know the relation, okay, if I know 2 of them, I should be able to find the third one. So if I want to find P, I have to know Q and R, which, okay, you are giving. So I'm going to find P, or we are going to find P. So first of all, with this one, you don't label it. Okay, I mean, you don't number it. Basically, okay, you cannot write maybe A, B, C, what have you. It's more or less, okay, your presentation, your work. So show with no number. Okay, so if Q is equal to 2 and R is equal to 8. Okay, this implies that, let's go. Our P will be equal to 6 times our R, which is 8. I hope you are following my professors.
Yes, please.
All over 2. Okay, so that will be equal to, we know, 2 don't multiply before you reduce. Reduce before you multiply. So 2 will go here 3. Hello, oh, it's 2 squared, right? Thank you.
Yes, please.
Okay, what happened to some of you in the exercise is exactly what has happened to me as well. It wasn't intentional. Okay, so please take note. Okay, so you should equally be careful. So let me calm down. Oops, what happened? Did I delete anything? What happened? Oh, did I go back or no issue? I think I have to write it again. I don't know what happened. Okay, so now we said if, forgive me, Q is equal to 1. Oh, sorry, Q is equal to 2 and R is equal to 8. This implies that your P, should be equal to 6 into R, which is what? 8, then over 2 squared. Okay, so that's where we were. So we'll get P to be equal to, remember, we'll deal with the power first, but let's multiply this and see. Whilst we are working on the denominator, we can work on the numerator as well. So this will give us my professors, are you there?
48.
Come again.
48.
Okay, so 48. So now you know that P will be equal to
12.
12. So immediately you get the value of P. Please come and write it there. Then you do same for the value of what? Of Q. Okay, so at that point, if I'm assuming this well, I mean, you can see that don't come and write there for P is equal to that. You were not asked to find P directly. So just write the value there. You get it?
Yes.
Okay, so you don't conclude when the question is not direct. That's my point. So assuming this is my next page, okay, I'll write if, okay, P is equal to 3 and, okay, R is equal to 16. I need to find, okay, my Q. So this implies that, remember I said, it's better you substitute and you do change of subject rather than change your subject before substitution. So I will get 3 is equal to, okay, 6 into R. So 6, your R is what, 16. Okay, all over your Q squared. Okay, so that in effect will give us 3 is equal to, hey, I'm waiting.
96.
96. Okay, so we cross multiply. This will give us 3Q squared is equal to 96. Okay, so what do? You write it again before you divide. Okay, so do all that you are supposed to do and give me the value of what? Of, what do you call it? Q. Will you write plus or minus? Okay, so I'm going to continue here. Okay, please take notes. I'm going to continue here. So let's continue there. All right. So that gives us 3Q squared again is equal to 96. Okay, then over 3 over 3. So you get what? Q squared is equal to 30,
32.
32. Okay, so you get root of Q squared. Okay, is equal to, per what you said. Let's see whether there is any information here talking about the value so you can see. Okay, so you should have underlined this. Do you get it?
Yes, please.
Okay, so if you underline that, and remember that's why I said anytime you are taking the square root, if you didn't underline, there is a second chance. So go back and check whether you have enough information to say that what you are looking for is really positive or negative. So once we went back, we realized that the Q must be strictly what? Positive. So if I'm taking the square root here, I will introduce the plus or minus. All correct.
Yes.
It will just be root of 32. Okay, which will give us Q, okay, to be equal to root of 32. Give me its what? Simplified version, if it is not simplified. Its basic version.
4 root.
Okay, so 4 root of what? Root of 2. So that's what you write here, 4 root of 2. All correct.
Yes, please.
Okay, so any questions? No questions, right?
Yes, please.
Okay, we thank God. So at this point, I am going to give you your water break. Okay, about 3 minutes. Okay, should do. Okay, so by 8:15, you should all be back. Okay, 8:15, you should all be back. I mean, we should be back to continue. So let me pause. Okay, so welcome back. Okay, from the water break. Okay, we are going to look at our last type of variation. Okay, which is partial variation. So this refers to a relationship between two variables in which one variable is partly dependent on another variable alongside an additional constant or other variable. I will throw more light on this, don't worry. Hence, in partial variation, a quantity is the sum. So here we are going to deal with sum of two or more parts, where some of the parts may be constant, while the other parts vary with other quantities. So some of the parts will be a constant, the other parts will be what? A variable, or will contain variable or variables. So take note. So for partial variation, the key word that you would always see, and you have to see, okay, is partly varies. So immediately you see partly varies, okay, you are talking about partial variation. And partial variation deals with the sum. Okay, whereas joint variation deals with what? The product. Okay, of the relationship that you are going to. So anytime you are dealing with a linear relationship, let me quickly say this. If you have a line, usually you say the line is equal to, so let's say y is equal to mx, okay, plus b. Am I right? Your line will always be of this form, or ax plus b. Is that okay? So this, you can see that y is related to these, okay, letters that we have here basically. Okay, but you can see some. So usually we'll say that y, okay, the b here is a constant. So y partly varies as what? As a constant, which is the b. And partly varies directly as the variable x. As simple as that. So with partial variation, you will see some. So you will see terms. But for joint variation, partly indirect variation and direct variation, okay, you don't see terms. You only see one term. Take note of that. That is the major distinction. So with that approach or understanding, let's look at how to move from the statement to the mathematical representation. Don't worry at all, you get it. I will break the concept here, okay, down, okay, when we are looking at what we are going to do here. So y varies partly as a constant. So this is it. Y varies partly as a constant. So let me use maybe, okay, let me use k, okay, as a constant. Okay, k, or let me use even c for constant, because this constant here is not a constant of variation. It's my point well made. This is just any constant. I hope you get my point.
Yes, please.
Okay, and okay, varies directly as x. So it means the same y is varying directly as x. Do you agree?
Yes, please.
Okay, very good. Now, the first statement that I have here, okay, I can say that this implies that y will be equal to k times c, where k is your constant of, what do you call it, variation. Do you agree?
Yes, please.
Okay, very good. And the second statement there, so this is end. Okay, end. And the second statement that we have there, I can also write y is equal to k times x. Am I right? Where again, k is what? A constant of variation. All correct.
Yes, please.
Okay, but very good. Take note of this. Just as I did for the joints. Okay, these two cases are constant of variations, all right, but they will differ. They will not always be the same. So because of that, I'm going to distinguish between them. So I will call this k sub 1 and k sub 2. All correct. Okay. Now at this point, remember we said whereas multiplication product is for joints. Okay. Sum will be for partial. Is that not it? So partial is for sum and joint is for more. So it means this time round, I am going to sum these two. So I will say that overall, okay, my y will be equal to k sub 1 c plus k sub 2 x. Is that clear? Hello, are you with me?
Yes, please.
Or if someone wants me to come again, please let me know. You know, this is the key. How we start here, how we can get our relation, okay, is key to whatever will happen afterwards. Okay, so now, remember we said the C here from the question, we said it's a constant. And the k sub 1 here is also a constant. And just as I asked in the previous one, a constant times a constant will give you
A constant.
a constant. So I can replace the whole of this by a constant k. Is that clear? Then maybe plus, okay, k sub 2, okay, x. Okay, so with this one, unlike the first three types, okay, where we had only one k to look for, you realize that with the direct, the inverse or the indirect, and the joint, we only had one k, one constant of what? Of variation of proportionality. You agree, right? But with this one, how many k's can you see here? You have 2k. So this one, each term will have a k. Okay, with the other one, remember we said we only have one term. So therefore 1k. With this one, you have two terms, therefore 2k's. Only that I am using k and what and k sub 2, but all of them will be constant anyway. Okay, Prof. Blaze.
I'm getting confused.
Okay,
Okay,
confused from where?
K, the y is equal to k plus k to.
This
You
one.
said that yes. You said you replace the two constants with 1k, but there are 2k.
No, you can see that I'm replacing this. This is a term. Okay, this term I have a constant times a constant. And a constant times a constant will give me a constant. So I'm replacing only this one by k.
Okay.
Okay, as for this one, it's a variable and a constant. There is no way a variable times a constant will give you a variable constant or a constant variable. In actual fact, we say that it's a variable. Okay, so we
Okay.
get to this one, but this one, because we know that it will give us a new constant. We are representing the new constant by k. It's still a constant though.
Yes, please.
You get it now?
No.
Great. Did I hear no?
Yes.
Okay, from where?
Okay, so wait, let me see. K is equal to y is equal to k1c and y is equal to k2x. And you're saying k1c is what? I didn't really get that part.
Okay, so remember, when we did the joints, when we created the two relations, we said joint, what do you do with the two relations? You multiply, is that not it?
Yes, please.
Okay, but with partial, what do you do with the two relations?
You add.
You add. So all of them is y. So it means y will be equal to this plus this. Is that clear?
Yes, please.
Okay, but I said there again, just as I said in the joint. Okay, remember from the beginning, we said this c here is a constant. Okay, remember, we said varies as a constant. You get it?
Yes, please.
Okay, so this is a constant. And when you introduce your equal to, you introduce another constant, but that's your constant of variation. Is that not it?
Yeah. Yes,
So
please.
K1, C. C is a constant. K1 is also a constant. Only that this is a constant that came from the question. This is a constant that came from the variation. You get it? That's a
Okay.
constant of variation. However, we know that constant times a constant will give us.
A constant.
So I replace the whole of this by a constant K. You get it?
Okay. Yes, please.
Okay, then we have this. So it means in actual fact, this is the relation. And I was saying that in this relation, how many constants do you see there?
2.
2, 1. Okay, once you have two terms, you are going to get two constants. And that was what I was explaining. For the first three, you know that always your relation will involve only one term. Whether the term contains one variable or two or more variables, what is important is you have only one term. But with this one, you have more than a term. And each term will contain a k. Therefore, I will have what? 2 terms here. Sorry, 2 terms in k. So I will have 2 k's.
Yeah.
Okay, and remember the other one will have 1k. And that k will always, we have to go and find it before we can get the exact relation. Okay, and therefore we needed only one equation. Here I have 2 k's. So in order to solve for these 2 k's, okay, I cannot find 2 unknowns with only one equation. So it means you have to get 2 equations before you can find your 2 k's. So for partial variation, you will always be solving equations simultaneously. That's the major difference. Is my point well made? However, the equations that you are going to generate, okay, take note, the equation that you are going to generate will come or will rely on the relation that will come from the statements. And that relation, you are going to write it. So if your relation is wrong, okay, the equations obviously will be wrong. So again, the key is to move from the statement to the mathematical representation, which you will use to generate your equations, just as we've been doing before. You get it?
Yes, please.
Okay, so now, okay, I have explained that. So going forward, by experience, you know, the first statement that you have here, this is what you are going to write, okay? And usually, let me put it this way, for partial variation, if you can move from the statement, okay, to the relation straight away without going through the variation statement, no issues. You can do that. Okay, however, I am going to move in that order, variation to the relation, just as we've been doing. So in this case, I will say that y varies, okay, partly as a constant, so C, is that clear? And whenever I see partly, I know that I am dealing with what? Partial variation, so I will deal with some, is that clear? So plus, with the same y varies directly as x, so it will be x. Is that clear? Should I come again? Please, this is the technical aspect of the types, the partial variation. Okay, that one you can see that, like I said, it's even involving. So make sure you ask questions for you to get it. And usually, most often than not, okay, subjective question, you either see joint variation or partial variation. Okay, we usually don't give a direct and indirect for, what do you call it, a subjective question, the paper 2. Direct and indirect, usually you see it in what? In paper 1. Is that clear? And you all know paper 2 is where the marks, okay, are. So please make sure you understand this. So if I'm moving, okay, from the variation statement here to the relation statement, then I'm going to get y is equal to, immediately I introduce equal to, there will be 1k multiplying this. Is that clear? Okay, so it will be a k times c, which will give me my first case. I'm going to call that one k sub 1. Then plus, it will be k times this x. I'm going to introduce a second case. I'll call it k sub 2x. Is that clear? This one, it will be your first k times c, which will also give you overall constant. So I'm calling that k sub 1. Is my point well made? My professors are silent. Okay,
Yes.
your silence is indeed, okay, what do you call it, loud for me. Are you fine, my professors? Is everyone okay? At least up to this point, you are fine.
Yes, sir.
Okay, great. Okay, so that will be it. Okay, Prof. Aduma.
Mr. Hackman, please, you see when you're solving for the first aspect, you made the K1 as in you presented it by K. So over here, why didn't you do the same?
Okay, remember, I could have even labeled this one as K sub 3. Okay, you are labeling your K. So anyhow you label your K is fine.
Yes, please.
You get my point. I decided to label this one as K. I could have used K3 just to distinguish. You get it?
Yes, please.
So these are just letters that you are introducing. So you can introduce any letter to represent your constant. As simple as that. But here, because I want to move alphabetic, that's why I use K sub 1, K sub 2, for you to know that you are dealing with 2 Ks. In some books, they will only write K, then K sub 1. What is important is that you have 2 constants in the relation, that's all. And you distinguish between the 2 constants. I cannot write K here and K here. Immediately I write K here and K here, then it means the 2 values of the K, mathematically, it will mean they are the same. That's the more reason why you always have to distinguish between them, because they will not always be the same. You get it?
Yes, please.
All right. Okay, so thank you very much. Now let's go and look at the other one too, if you are fine. So the second statement, okay, y varies partly. So immediately you see partly, okay, you know that you are going to deal with some. It's partial variation. So y varies partly as a constant. So meaning y varies partly as a constant. I'm using C for my constants. Okay, and varies inversely as the square of x. Okay, so it will be plus, okay, 1 over, because it's inverse, square of x. Do you agree?
Yes, please.
Okay, now we'll move from this to, so that implies that unfortunately it won't go there. So yeah, so I'm bringing it down. So y will be equal to, immediately I introduce equal to, there will be a first k, constant of variation multiplying this. So that will give me k times c, which is a constant times a constant. It will give me a constant. So my first constant, I'm writing it, I'm giving it the name k sub 1. Is that clear?
Yes, please.
Or if you like, you can write overall k. Okay, all right, you can do that. Then plus, okay, this one too, I will introduce a constant of variation. So I'm introducing a second constant of variation, and I'll have a second constant, and I'll call that one K sub 2. Okay, all over, okay, S squared. All correct.
Yes, please.
Okay, so you can see that though it's a little technical, but if you try to follow, okay, my explanation, you will be able to get it. It's not difficult at all. Okay, so now this will be it for the second one. Someone, okay, should convince me that indeed you are on track. Okay, by taking us through the, what do you call it? The test statements, its mathematical representation. Anyone who wants to try? Hello, who wants to try? Oh, please, my professors, are you there? I'm waiting. Who wants to try? Okay, Prof. Ama Zakuma, let's go.
Okay, sir, please. So
Mhm,
y very partly as a constant, so it will be y and the variation sign
mhm.
c,
Okay,
and jointly as x and z, so it will be plus xc.
very good. Uh-huh.
So this implies that y is equal to k1 plus k2x
K2,
xc.
XC, very good. Thank you very much. So you can see that again, I have introduced, what I introduced here is defined here. So all the K1, K2 that you see there, we said they are constant. The reason why, okay, and take note, this is going to seal it before you move on to the next, okay, slide. Okay, the reason why I wrote, okay, here, K1, K2 are constant, but I cannot write they are constant of variation, is that with this one, the K2 here is a constant of variation, but the K1 here is not automatically constant of variation because it's constant of variation times another constant. You get it? It was a constant of variation times another constant that gave us a new constant. So your new constant here is not really a constant of variation. You get my point? So we joined variation. Okay, when you are defining your constants, okay, don't attach variations. Just write constants. Are constant. Even with the other ones, did I say with joint? Sorry, with partial variation, you have more than one constant. Okay, so make sure you just represent them by constant. That's all. Okay, they are constant. Don't attach variation constant, what have you. Other than that, it will be flawed, especially the first constant. Take note of that. Okay, so before we move on to the next page, let me see. Okay, if you have this, y is equal to, let's say, let me use, okay, x plus, okay, 2x plus maybe 3z. Okay, how would you state this in the variation statement form, in this form? How would you write this in that form? The form that you have in this form before you can write it this way. Who wants to try? If you're able to get this, okay, then you have arrived. Anyone who is able to get that, okay, will be rewarded beautifully and handsomely.
Yeah, please, the question again.
Okay, so assuming maybe you have a relation which is this way, I want you to move from this relation to the statement. How would you state this relation in this statement form, in the variation statement form? Okay, I guess you are thinking about it. Okay, so at this point, let me give you some few seconds to think about it. Let me pause. Okay, then when you are ready, you put up your hand. Okay, so Prof. Chrysler, after that, then Natalie. Natalie hoping that Chrysler will get it wrong. Okay, so hey, Prof. Chrysler, hey, let's go.
Mr. Hackman, why varies partly Z
Partly,
and varies yeah,
why varies
as X
partly?
as X
Mm-hmm.
and varies directly as Z.
Z. Okay, that is Chrisless what answer. Okay, Prof. Natalie, I've not placed any judgment, okay, on your answer yet. Prof. Natalie,
Okay, so y varies partly as the constant 2 and varies directly as z.
Z. Okay, so you can see 2 here, you can see 3 here. I think you don't like 3. Why didn't you mention the 3 here?
The 3 is a constant, but then I
The
don't
3
know
is not a
what
constant.
the 2 is also a constant.
Okay. Anyway, okay, so I am going to judge. Okay, Prof. Kessler, okay, I'm clapping for you, but I'll give you something for chocolate. Okay, that is it. Okay, you killed it, you nailed it. Okay, so please take note. Once you see a variable here, I've told you, immediately you see sum, you are talking about what? Partial. Okay, so here, remember we said you either see a constant, okay, or you see variables, but you are going to see sum. So this means y varies, okay, partly as x. And remember, any part that you have, it will always have a constant, okay, before it. That's your constant of variation. Any part will have a constant before it. That's why you see this constant too. So partly, okay, varies as x and what? As z. And if you move from the variation statement to the equation statement or relation statement, you see constant attached to what? Your z and your x, your variables. But here, it should have been maybe k1 x, then k2 what? Z. But we know the actual case, so that's why they are there. Is my point well made?
Yes, sir.
Okay, so please, okay, Chrysler, prompt me after class via WhatsApp message, okay, to send you something for your chocolate. Okay, or you want a virtual chocolate?
Oh no.
Well, I know, right? I'm just pulling your legs. Okay, Prof. Amma.
Sir, please, you said the statement to be y varies partly as x and as z, and not
Mhm.
varies directly as z.
Yes, and not vary. If you say varies directly as Z, okay. No, come again.
Sir, please,
let me.
why did you say the statement to be y varies partly as x and as z?
Okay. So immediately you see plus. What type of variation are we dealing with?
Partial variation.
Partial variation. So it means in your statement you should add partly. Is that
Yeah.
okay? Okay, so it
Yeah.
means y varies, okay, partly as this and as that. Is that clear? But when you come here with this one, there is what? A variable. So it means that it varies partly as that's your variable and also your second variable. So if you have this, okay, in that same vein, if you have this, how would you treat this in terms of the variation? Y varies directly because immediately, sorry, did I say directly? Partly. Okay, immediately you see plus, partly should come in. And partly as this. This one, do you see any variable there?
No.
No, so it means you shouldn't take any variable. So you see only a constant. So partly as a constant and partly as a variable. But what's the name of your variable?
X.
X.
Oh, okay.
You get it? You can see that in actual fact, this is the equation of a line indirectly. This one, I gave it in the general form. So I can as well say this. And you can equally, I can as well write this as this. And so you can write or put your statement this way. Y varies, okay, directly, partly, forgive me, partly as what? X, and partly as a constant, and as a constant. You get it? Only that usually we will mention the constant first, followed by the variable.
So it's not really necessary for us to write and varies directly as X.
Yes, you know, immediately I've told you, okay, remember, I've told you, if the word direct is missing, it means you are still dealing with direct.
Okay.
Okay, so instead of saying varies directly as X, I can say varies as X. You get it?
Yes.
So there is nothing wrong with that.
Okay.
Okay, all right. You are welcome. Okay, so if my point is well made, then I guess we can, okay, look at maybe 1 or 2 examples, then we'll bring the curtains down. So let's look at the first one. Okay, with this one, you know, simultaneous equations. Obviously, we are going to do a little more work. Okay, that's all. So what is simultaneous equation doing in variation? You see, that's why I've told you in math, you don't pick and choose the topics that you like. You like all the topics, but you can love, okay, some of the topics more than the others. So that's okay. So now what do? We have what? Solution to question number 1. Okay, under this type. Okay, a variable y, partly. So immediately you see partly, you are good to go. So for me, and going forward, this is how I will expect you to also write what's your solution. So y, okay, if you like, going forward, the first one, I won't handle it maturely. Y varies as a constant, so let me use my C. Okay, and so partly is partly. So, and again, here, partly is repeated twice, but 1 is okay. It's necessary and sufficient for you to know that you will deal with some. And partly varies as the inverse of the square of x. So once it's inverse, okay, it's going to be a denominator by the square of x, so 1 over s squared. Point well made. Okay, so I am going to have, this implies that, okay, at this point, I move from the variation to the relation. So it will be k times c, which will give me my first k. So I will call it k sub 1. Then plus another k times this, because k times c, a constant times a constant overall will give you a constant. So that's being represented by k sub 1. Then, okay, k times this, there is only one. So my second k, I'll call it k sub 2 all over s squared. So I've introduced 2 k's. So I'll write k sub 1, okay, and k sub 2, okay, will be equal to constants. Or someone can write k sub 1, comma, k sub 2 constants instead of the n. Remember, I've told you in math, we can use comma also to represent n. All correct. Is my point well made, my professors?
Yes, sir.
Okay, so now let's see. I have 2 k's. So before I can write the relationship between x and y, okay, and remember I've told you, whenever we are asked to find the relationship, okay, then it means your only letters there should involve your values, your letters of interest here, or your variables here, which will give you y and what and x. So we need to go and find k sub 1 and k sub 2. That's all. But in order to find k sub 1 and k sub 2, obviously 2 unknowns, so we need to generate 2 equations. So the first equation will give you enough information, will come from this statement. Okay, the information here. So if, okay, x is equal to 4, okay, and y is equal to what? 12. Okay, this implies that, so that's going to be using this information to generate the first, okay, equation. So I'm going to get what? 12 is equal to k sub 1, okay, plus what? K sub 2 over 4 squared. Do you agree?
Yes.
Okay, so this will give me 12, okay, is equal to k sub 1 plus k sub 2 all over 16, all correct. Okay, so like I've been saying and I keep saying, this equation, you can label it here, but okay, usually we don't label equation, okay, with containing a fraction. So we are going to clear the fraction. So let's go. You multiply through by the LCM, which is 16. So 12 times 16, I'm waiting for you, my professors.
592.
592.
592.
Come again, 192. Hello, is that what you said?
Yes, please.
192.
Come again. 192. Okay, 192. Okay. So let's go. So 192. Okay, is equal to K sub 1. So it will be 16 times K sub 1. So 16 K sub 1. Am I right?
Yes.
Then plus what? K sub 2. But usually we know we want to write our terms with unknowns here. And by the same, we can label it here. Okay, so meaning when you are moving from here to this, you write it in that form. So you skip this and come and write 16, okay, K sub 1 plus K sub 2, okay, is equal to 192. And that becomes your equation 1. All correct? Okay, then you come to, okay, if, go for the second statement, X is equal to 6. Okay, and Y is equal to 20. Okay, this implies that here, let's go, 20 will be equal to, we come and substitute that here, okay, in this one. So you get what, K sub 1, then plus K sub 2 over what, your X, which is what, 6 squared. Okay, so that gives us what, 20 is equal to what, K sub 1 plus K sub 2 over 36, am I right?
Yes.
Okay, over 36. So again, we are going to clear the fraction before working with it. So that will give us what? The LCM will be what? The LCM will be 36. So each term by 36, okay, will give us 20 times 36, 720, am I right?
Yes, please.
Okay, so 720 will be equal to 36 times K sub 1. So 36 K sub 1. Okay, and I should have written it in that form again. So then K sub 2. Okay, so I could have left it in this form and label it. Okay, I'm mature. I could have done so that also here as well. But I just want it to reflect the usual one that you see. So on that note, I'm going to write this. 36 K sub 1 plus K sub 2 is equal to 720. So now we are going to solve these two equations simultaneously. Then we'll know the relationship between X and Y. So let's see. Okay, you can see that if you listen to these two equations, okay, I've told you whenever you are solving, listen, the equations will tell you, they will tell you the appropriate, okay, method to use. So here, listening to, okay, if I want to use elimination, coefficients of the K1 not the same, so I have to multiply before I can eliminate. K2, they are the same, so I can easily eliminate K sub 2. Is that clear?
Yes.
So we are going to do the bigger one. If I eliminate K sub 2, my result will be in K sub 1. So the bigger K sub 1 is in equation 2. So I'd rather do equation 2 minus equation 1. So look at the way I didn't write equation 1. So I mean equation in 4, just write this. Or don't write put this, okay, please. Or subtract, just write this. It carry the same meaning. So that would be 36 K sub 1 minus 16 K sub 1. And that will give us 20 K sub 1. Am I right?
Yes.
Okay, then the K sub 2 minus K sub 2, that will go. That's your intention. And this must be equal to 720 minus 192. I'm waiting. 528. But we are looking for K sub 1. Write it again before we divide. All correct?
Yes.
Okay. So over 20 over 20. Okay, so K sub 1 will be equal to
26.4.
26.4. If possible, please avoid decimals, remember. So this means corresponding reduction. Come again.
1325
132
and 5.
on 5. Okay, so this becomes your equation what? Equation 3. Okay, we will need equation 3 to find, okay, K sub 2. So 3 into which equation? Equation 1 and 2, which one do you prefer? Equation 1, of course, because it involves smaller values. Am I right?
Yes, please.
Okay, so into equation 1. And that will give us, okay, please continue. I don't know, let me mute the person whose audio is interfering with us. Okay. So at this point, this is what we are going to get. 3 into 1. Okay, wherever we see, what do you call it? K sub 1 in this, we substitute what we have here. So we are going to get here 16 into what? 132 over 5. Okay, here let's go. Plus K sub 2 is equal to 192. Am I right?
Yes, please.
Okay, so use your calculator to do this. I'm waiting.
2112 on 5.
2112
Yes, please.
on 5. Okay, plus K sub 2. Okay, is equal to 192. Okay, so in this case, I can say that K sub 2 will be equal to 192 minus this. I'm waiting. Okay, so whilst waiting, let me go and duplicate this. I don't think I duplicated it, so that I will have room to continue. So I'm waiting.
Negative 1152 on 5.
Okay, so negative
52.
1152 onwards on 5. Not that pretty, but okay. And you can see that here we are not concluding with it. That's the more reason why we didn't change to what mixed numbers. Is that clear? They are only means to an end. Okay, so now let's continue to the next page. Okay, so the next page, it means now we are done with A. So all that we are doing here, immediately we started doing this. Okay, we were looking at the solution to A. Do you agree? So the A solution starts from here. So now let's go and continue. So it means your Y will be equal to, you have the value. So I will call on you for the two values here. And when I call on you, please be, okay, very fast for me. So it means, okay, therefore, my Y will be equal to K sub 1, which give us
132 on 5.
132 over 5. Okay, then it will be plus, okay, it's plus K sub 2 over this, but K sub 2 is negative. So it will now be minus. Do you get it? So it will be minus this then over S squared, but we'll deal with this later, simplify it later. So let's move on. So it will be minus, let's go. What's your fraction? Or let me write plus minus. Let's go and do direct substitution. Minus
152.
52 over 5. All over X squared. Is that not it?
Yes,
So which
please.
in effect will be equal to 132 over 5. This plus and minus will make it negative. And remember, this denominator will come and multiply this. Do you agree? So it will be 1152 all over 5x squared. All correct.
Yes, sir.
Okay, so at this point, okay, you are in a comfortable lead. So what do? We are going to look at, so we are done with A, B. If, okay, Y is equal to 5. Okay, now Y is only in terms of X. So you can predict X knowing Y, you can predict Y knowing X. And that's what the question is asking us to do. So if Y is equal to 5, we are going to get, this implies that 5 will be equal to 132 over 5 minus 1152 over 5s squared. All correct. So you can see that with the partial variation, just as I said, it is the algebra that will be involving. So if you know how to deal with partial variation, the other 3 will be trivial. Okay, because usually the work in that one. Okay, so no, I've left something out, right? It's 5x squared. Am I right now?
Yes, please.
Okay, so let's go. You know you are solving for x. Okay, so what do we do? First of all, I will tell you to move this one to this side and move this one to this side. Or someone will say that multiply through by the LCM. And what will be the LCM? 5s squared. Do you agree?
Yes, please.
Okay, so let's do that and see. So this one times 5s squared will give us 25s squared. Am I right?
Yes, please.
It's equal to this one times 5s squared. The 5 will cancel. So I will get, okay, the 132s squared. Am I right?
Yes, please.
And this one times 5s squared. The 5s squared will cancel. So I'll get minus 115 what's 2. Okay, I'm looking for x. I collect the terms in x on one side, but I always want to avoid negative because the x squared here is bigger. I'd rather move this one here, move this one here. Is that clear? So I'm going to get 1152 is equal to 132s squared minus what? Let me write it just for explanation purposes. Then minus what? 25s squared. But I've told you, you can always do this mentally. So let's go. So ideally, we are supposed to move from this step to the one that I'm going to write. So 1152, okay, is equal to here. I'm waiting the difference. 132 minus 25.
107.
107. Okay, 7. Very good. X squared. So what do? We write it again before we divide. 107 x squared over 1152 all over 107 all over 107. So x squared will be equal to, here I'm waiting.
The same thing.
Okay, so you can't reduce, right?
Yes, please.
Okay, so if you can't reduce, then you are going to get 1152 over 107. So you take the square root of that. Okay, do we introduce plus or minus here? So you ask yourself, do you have any valid information, okay, to say that it's really positive? No. So plus or minus. Okay, then root of 1152 over 107. Make sure this extends to cover the denominator. So not that pretty. But I think there is something, maybe the values that I have there that maybe, okay, when I was dealing with it, okay, so I will check again because usually we won't give you something that will give you this, okay, ugly result. But if that is the question, you deal with it. Is my point well made?
Yes, sir.
Okay.
Yes, please.
If past time. Okay, so this is the first. So in our next meeting, we'll continue with the partial variation. Then we'll solve, okay, past questions. Okay, so your assignment will come. I wanted us to do a classwork, but unfortunately, time, okay, they didn't allow us to do that. So I will give you an assignment, and I think that will be on only the joint board variation. Okay, so thank you very much. Okay, so bye-bye.
Bye-bye.
Bye.
Okay, we'll meet.
Bye.